there. Thanks for stopping in. You know what chopping wood, splitting wood makes me think of fractions. Halves, quarters, eighths, you name it. And while I was thinking about fractions, I actually got to thinking about exponents. And how we talked about how 0 could be an exponent, and so could -1, and so could -2, and so on. And I got to thinking, what if we put the idea of fractions and exponents together? I know an exponent can be 1, I know an exponent can be 2. Could an exponent be a half? Or a third? What does 2 to the power of a third mean? How about 5 to the power of 2/3? Do those mean anything? Come on, let's go learn together.
So last week we talked about powers and exponents and how exponents could not only be 0, like 2 to the power of 0, but they'd actually be negative numbers as well. And we found that 2 to the power of 0 is equal to 1, and 2 to the power of -2 is equal to 1 over 2 squared, or 1 over 4, and so on. So the next question that mathematicians started asking themselves is it possible to have an exponent that is a fraction or a rational number? Can we extend our definition of exponents and include those? So for example, does it make sense to talk about 2 to the power of a half? Does it make sense to talk about 5 to the power of a third? And so on. We're going to answer that question today. Let's start with 2 to the power of a half. I mean, one thing we have to notice is that this is 2 to the power of a half and not 2 and a half, which is 2 plus a half. So we need to be really careful with our notation, that we're really obvious that this is in fact an exponent and not just a mixed fraction. Let's go back to the pattern that's formed by powers of 2. We did most of this last week, so of course we have our powers of 2. I'll add our negative ones. 2 to the power of -1 is a half. 2 to the power of -2 is 1/4. 2 to the power of -3, 1 over 2 cubed, or 1/8. And we have this idea that every time the exponent goes up by 1, we multiply by 2. And we used this pattern to actually figure out these values here last week, what to do if an exponent was negative. We can kind of do the same thing to think about 2 to the power of a half. So if 2 to the power of a half is going to mean something, obviously it should be a value that's in between 2 to the power of 0 and 2 to the power of 1. So it's got to be in between 1 and 2. Now your first guess might be to say that it's 1.5. And you know what? It's actually probably not a bad estimate. That's halfway between 1 and 2. Unfortunately, though, that's not correct. If you're thinking that way, you're thinking about a linear pattern. A linear pattern is like these values going up by 2 each time, like 2, 4, 6, 8, 10. They're not going up by 2, they're multiplying by 2. And so splitting the difference between 1 and 2 doesn't actually give you the exact value that 2 to the power of a half would be equal to. So this is a difficult question. If we take one full step, from 0 to 1, we multiply by 2. But what if we take 2 half steps? What's the same as timesing by 2 that we could do twice? And as it turns out, 2 is actually a bad number to work with here. So we're going to come back to this. Instead, let's move on, and let's actually look at powers of 9, because we're going to see powers of 9 are actually a little easier to deal with in this example. So here's my powers of 9. Oops, that should be 9 to the power of -2 there, which is, of course, 1 over 81. 1 over 9, and the rest of the powers of 9 are filled out for you. Now with powers of 9, instead of multiplying by 2, we're obviously multiplying by 9. Okay, and that continues even with the negative exponents. Well, we might ask the question, what about 9 to the power of a half? That's exactly the question we're going to look at right now. What is 9 to the power of a half? What would that have to mean? Sorry, sometimes my pen here doesn't work very well. Easy. There we go. Sorry about that. 9 to the power of a half. What does that got to be equal to? Well, obviously 9 to the power of a half should be between 9 to the power of 0 and 9 to the power of 1, since that's where the number 1/2 belongs. So what should it be? Well, we want a value so that the pattern that we have holds. Every time the exponent goes up by 1, we're multiplying by 9. So from 1 multiplied by 9 gives you 9. So instead of increasing by the exponent by 1, imagine we instead increased it by just a half. So instead of multiplying by 9, we're going to multiply by something twice that's going to be the same as multiplying by 9. What number could you multiply by twice that would be the same as 9? Well, that answer is 3. 3 times 3 is the same as multiplying by 9. So we can kind of look at going from 9 to the power of 0 to the 9 to the power of 1 as either taking one step where we multiply by 9 or taking 2 half steps where we multiply by 3 each time. And sure enough, we want that because there's an exponent of a half there. It's okay if you're a little confused. It's not simple. Let's look at powers of 4, which you're soon going to see work out nicely as well. 4 to the power of negative 2 is 1 over 16. 4 to the power of 1/4, and the rest are already there for us. Of course, just like before, 4 to the power of a half is going to be halfway in between 4 to the power of 0 and 4 to the power of 1. I'm saying halfway. It's not the middle of 4 and 1, though. When we go from 1 to 4, we multiply by 4. In fact, we're timesing by 4 every time here. So what could we do? What would be the same as multiplying by 4, but instead are 2 sort of half steps? Well, if you want to change a 1 into a 4 only by multiplying, and you want to do it twice, you can see that. Look at that little hint there. I already wrote 2 for you. Multiplying by 2 twice is the same as multiplying by 4. 4 to the power of a half is actually equal to 2. Now, what's that mean for our previous example? And why is it more difficult? Back to our powers of 2 again. What is 2 to the power of a half? Well, every time our exponent goes up by 1 with powers of 2, we're multiplying by 2. So what could we multiply by twice that would be the same as multiplying by 2? So what times what is the same? So take that number 1. Instead of multiplying it by 2, what could you multiply by twice that would be the same as 2? Well, that answer is the square root of 2. The square root of 2 is a number that when multiplied by itself will give you 2. And so that's what we want here. And 1 times the square root of 2 is the square root of 2. So 2 to the power of a half is equal to the square root of 2. In fact, that idea held up over here as well. 9 to the power of a half is equal to 3, and sure enough, 3 is the square root of 9. 4 to the power of a half is equal to 2, and sure enough, the square root of 4 is equal to 2. In general, anything to the power of a half is equal to the square root of a. So the power of a half and taking a square root are actually the same thing. Still a little confused? Well, that's okay. It's not easy. Let me show you something else as we move on that might actually explain this just a little differently. There are other ways of looking at this as well. As we're looking at that, we might also come up with some other questions too, and that's, okay, if 9 to the power of a half is equal to the square root of 9, which is 3, well, what about 9 to the power of a third? What about 2 to the power of a quarter? I mean, a half isn't the only fraction that's out there. Well, let's take a look at that now. And as we're doing that, we're going to kind of review powers of a half as well. So look at an expression like 4 to the power of a half times 4 to the power of a half. Since those are both powers of the same base, we'd like to think we can add their exponents. And a half plus a half is equal to 1. So we'd think that that should be 4 to the power of 1. Well, look what you just did. You took 4 to the power of a half, and you multiplied it by itself, and you got 4. Well, whatever 4 to the power of a half is, it should be the same here as it is here. So 4 to the power of a half must be 2, because 2 is the only number that you can multiply by itself to get 4. Sure enough, that's also the square root of 4. The same argument can be made for a number like 5. Even if I don't know what 5 to the power of a half means, I would like to think that I should be able to add the exponents because I'm multiplying powers of the same base, which means I get 5 to the power of 1, or just 5. Well, look what I've done now. I've highlighted these two numbers. I've multiplied that number, 5 to the power of a half, by itself, and I got 5. Clearly, these two better be the same number. So when I multiply a number by itself and got 5, well, what's that number? Well, that's usually what we think of as the square root of 5. The number that when multiplied by itself will give you 5. And it's, I don't know, 2.2 or somewhere in there. Well, let's move on to this. What about 8 to the power of a third times 8 to the power of a third times 8 to the power of a third? Well, even if we don't know what power of a third is, which you probably don't know right now, we would like to think that we can add those exponents together since they're all powers of 8. Well, a third plus a third plus a third is 1. 8 to the power of 1, or just 8. So look what I've done now. I've taken this number that I'm highlighting and I've multiplied it by itself 3 times, and I got the number 8. It's kind of like this right here. Well, what is the only number that fits here? Hopefully by now you realize 2. 2 is the only number that fits here. So 8 to the power of a third has to be 2. Well, 2 is also sometimes referred to as what's called the cubed root of 8. Now, if you've never seen a cubed root before, it has the square root sign with a little 3 here. And it means the number then when multiplied by itself 3 times will give you 8. Or the number when raised to the power of 3 gives you 8. That, of course, is 2. And 8 to the power of a third is equal to 2. By the way, the square root of 5 and the cubed root of 8, anything involving any type of root sign is called a radical expression. You like that term? Radical expression. I told you math was cool. Let's look at the next one. 32 to the power of a fifth. Sure enough, I've written it out 5 times. Well, powers of 32, we'd like to think we can add their exponents. A fifth plus a fifth plus a fifth plus a fifth plus a fifth is equal to 1 5/5. So that expression is equal to 32. So that means, again, we've multiplied the same thing by itself 5 times, and we ended up with 32. Well, that means what number do I multiply? Sorry, I'm going to erase that. What number do I multiply by itself 5 times to get 32? Well, the answer is again 2, since 2 to the power of 5 is equal to 32, but we also call that the fifth root of 32, which is equal to 2. Now, I know what you're thinking. How do you know so quickly that 2 to the power of 5 is equal to 32, or that 32 to the power of 1, the fifth root of 32 is equal to 2? Like, how did you know this so quickly? Well, the short answer is I'm a math teacher and I do math all day long, and after a while you just start to remember some of these things. But one thing I'd encourage you to do is to access that powers chart I've talked about, and the one I pulled up is right here. It's not the greatest one, but there it is. It shows you all your powers, bases, and exponents. So here's 2 to the power of 5, 2 to the power of 5, okay, and we cut across, sure enough, we get 32. So often when you're dealing with radical expressions, you might see something underneath the root sign and then go to the powers table and see if it's anywhere in the powers table. Oh, there's a 32. Look, 32 is 2 to the power of 5. Oh, so the fifth root of 32 is equal to 2. So that's where that powers chart's useful. It's a little easier than using a calculator even in some cases. In general, notice what we found here. That 4 to the power of a half was equal to the square root of 4. That 5 to the power of a half was the square root of 5. That 8 to the power of a third was the cubed root of 8. And 32 to the power of a fifth was the fifth root of 32. A to the power of 1 over n is then the nth root of a. And that's the next rule. Now, that means that 81 to the power of a half is the second root of 81. Now, we don't usually write the 2 here, but you can if you want. It's just like square roots have like an invisible 2 there. It might not be something you know. Okay, square root of 81 is, of course, 9. Okay, 62 to the power of a quarter is the fourth root of 2. Sorry, fourth root of, look at me giving away the answer again. The fourth root of 16. So what do you multiply by itself 4 times to get 16? Well, 2, or 2 to the power of 4 is 16. Again, in my powers chart, I happen to see that 16 is 2 to the power of 4. 25 to the power of a third is the third root of 25. Now, that's a little interesting because, of course, I can't think of a number where that works out. If I look at my power chart, the only 5 is 5 squared. Or so the only 25 is at 5 squared. And I'm looking for a cubed root, not a square root. So what do I multiply by itself 3 times to get 25? I don't know that answer. So that's my exact answer. I might want to put that in on a calculator and come up with like an approximate answer. And I can do that too. Different calculators work differently. Some calculators have a cubed root button. Some calculators have a button maybe that looks like this, with a little X or a little Y there. And you can certainly try to figure out how to use that button in your calculator. Now on mine, I don't even have that. But here's the nice thing. I don't really, I have an exponent button. If I just want to know what 25 to the power of a third is, I can just use the exponent button. I don't need to use a radical button. 25, and I hit my power up button, and I need to go brackets here, 1 divided by 3, end bracket. I have to equals, it's about 2.92. It's also kind of nice, you have another way of, if you can't find the square root button on your calculator, you can just do the power of a half, because the power of a half is the same as a square root. Now we have 2 different forms for this answer, this expression here. This is what's called exponent form. And in this one, you switched it to what's called, you guessed it, radical form. And then this, of course, at the end is just our approximate answer. Okay, last one. 16 to the power of, I hope you can see that, that's actually a negative 1/2. Well, first thing we can do is our rules about negative exponents. That's the same as 1 over 16 to the power of positive a half. Just like 2 to the negative 3 was 1 over 2 cubed. Well, now it's just the power of a half instead, and we know the power of a half is the same as a square root. So the square root of 16, of course, is 1/4. And there's our answer for that one. Now, if we look back at this rule, you might realize that only helps us with some fractions, a half, a third, a tenth, and so on. There are, of course, more fractions out there where the numerator is not 1. How about 81 to the power of 3/4 and 8 to the power of 2/3? How might we evaluate those? Well, to start with, 81 to the power of 3/4 should be between 81 to the power of 0 and 81 to the power of 1. Of course, closer to 81 than 1, because 3/4 is a lot closer to 1. But what exactly has it got to be? Well, thankfully, we have a nice little trick we can do here. We can rewrite this using our rules for power of a power. 81 to the power of 3/4 should be the same as 81 to the power of a quarter taken to the power of 3. 3 times a quarter is 3/4. Well, 81 to the power of a quarter we already know is the fourth root of 81. And then if we take the fourth root of 81, well, let's just take a look. I notice there's an 81 here under 3 to the power of 4. 3 to the power of 4 is 81, which means the fourth root of 81 is 3. Since 3 times itself 4 times will give you 81. Well, 3 to the power of 3 is 27. So 81 to the power of 3/4 is 27. How about 8 to the power of 2/3? We can do the same kind of thing. 8 to the power of a third squared. Well, 8 to the power of a third is the third root of 88, The third root of 8 is 2, and 2 squared is 4. Now you might notice a bit of a pattern here. Take a look at 81 to the 3/4, and that's what it ended up being in radical form. 8 to the power of 2/3, and there it is in radical form. Notice the 4 with the root, the 3, the exponent, the 3 with the root sign, and the 2 is the exponent. So we do have a rule. We say that a to the power of m over n is the mth root of a all to the power of n. Now, as it turns out, that's actually the same as doing the mth root of a to the power of n as well. So you can use either of those. They're both going to give you the same thing. Let's take a look at some other examples. 15 to the power of 2/3. Okay, according to our rule above, that should be the cubed root of 15. Do I want to square it here or square it? It doesn't really matter. You can write that, or you can write, I don't know, this just looks a little bit, I don't know, slicker. I'm going to tell you something, though. I don't know what the cubed root of 15 is. I know 15 squared is 225. Well, I could try that. But I don't know what 225 is as a cubed root either. If I take a look here, I'm going to find, I just don't think I can find a 225 anywhere on here. So the cubed root of 225, maybe that's my final answer in radical form. Maybe I want to know approximately how much that is, in which case I can go to my calculator. I can type in the cubed root of 225, or I can type in 15 to the power of 2/3. I'm going to do 15 to the power of 2/3. To the power, bracket 2 divided by 3, so we put 666, there it is. And on my calculator, I get out 6.08. That makes sense to me. Okay, now we've got a fraction, 9/16 to the power of 3/2. Well, now I can start thinking about some other things I've learned about fractions. And that's this little rule that we've talked about already. So I can apply that here. This is 9 to the power of 3/2 divided by 16 to the power of 3/2. Okay, notice I'm not doing a very good job of making my exponents look like exponents. Right? That's 9 to the power of 3/2, not 9 3/2, which would kind of be ridiculous too. But in any case, 9 to the power of 3/2 is the square root of 9 cubed. And 16 to the power of 3/2 is the square root of 16 to the power of 3. Notice I chose to put my roots first and my exponents on the outside because I know how to do the square root of 9. I know that that's 3. And I know how to do the square root of 16. I know that's 4. Gives me 27 over 64. So you could have, so that's how you finish that off. You could have instead, as I went from here to here, I could have chose to have put the cube inside the brackets and cubed 9 and then rooted it. But, I mean, just easier without a calculator to deal with smaller numbers when you do it this way. But either way, you get the same thing. 25 to the power of 3/2. Okay, according to our rule, that is the square root of 25 cubed. Do you want to put the 3 here? I don't, because I know the square root of 25 is 5. And I happen to know that's 125. Negative 27 to the power of 2/3. So according to our rule, that's the cubed root of negative 27 all squared. Okay, here's the interesting thing. You can take cubed roots of negative numbers. The cubed root of 27 is 3. 3 to the power of 3 is 27. Negative 3 to the power of 3 is also negative 27. And so it makes sense in this case to sometimes have a base that's a negative number. Negative 3 squared, positive 9. And there you have it. We can now talk about exponents that are negative, that are 0, that are fractions that are in between the whole numbers as well, and we're able to understand that. If you're finding exponent questions difficult, especially when we combine rules, like in fractions with, fractional exponents, that's it's normal to find it challenging. So I've got some questions for you to try. And after this, we'll probably do a bit of review as well, just to sort of go over things again. If you don't have your textbook at home, please check my email for instructions on how you can actually access our course's textbook online for free. Okay, bye for now.